Hello there. Just gonna kind of explain my way through these notes. As you can see, they're already done. Right here it says, understand that compound interest means you earn interest on your interest. Makes sense, right? Compounding the interest. You earn interest on interest. And understand how to substitute into and apply the compound interest formula. So, two main understandings, right? How to use the formula, what each input, what each variable is. So you input the correct values, and then just knowing that like compound interest continues to add to the principal, right? And you eventually earn interest on interest. So having an understanding of that is just helpful for your future like financial savviness. So anyhow, here's your formula for the future value of a loan or investment using compound interest. A equals P times parentheses 1 plus R divided by N to the power N times T. That may seem like it has a lot going on, but it's actually not too bad. A is still the future value, P is still the present value, R is still the rate, T is still the time. There's only one new variable here, N, and it stands for the number of compounding periods, meaning how many times they compound, the bank, that is, how many times the interest gets compounded per year. So as you can see, if if something gets compounded annually, N is just 1, so that really doesn't matter. If it gets compounded annually, you really don't need the 1 in here for N. Other than that, though, semi-annual would mean N equals 2, so you'd have to plug in a 2 for N. If the problem says interest is compounded semi-annually, if it says quarterly, you have to put in a 4 for N. Like this first problem says it's compounding quarterly, so I would plug in a 4 for N. If interest gets compounded monthly, then there's 12 compounding periods, right? Remember, this is the number of compounding periods per year. If it gets compounded daily, there's 360 compounding periods. So N would be 360. Then over here on the side, I write that weekly. If you compound interest weekly, then N is 52. So depending on the words, it'll determine what number you put in. So I have my formula, and it says find the amount of money in the account after 3 years. So there were some details up here. You deposit $2,000 at a 6% rate compounded quarterly. So depositing $2,000 makes that the principal or present value. The rate R is 6%, so 0.06, and I'm compounding quarterly in this scenario, so N equals 4. And then all I have to do is plug all those values in correctly. So again, I'm trying to find the future value using this formula. I'm going to plug in the 2,000 for the present value, as you can see here, times 1 plus R, so that's 0.06, as you can see there. Divide by N. Remember, this one had quarterly compounding, so N is 4, and then T is, where did that go? 3 years, so T is 3, so you can see that right here. And so anyhow, just once everything is accurately plugged in, you can just kind of follow the order of operations to solve it. So in the parentheses, 0.06 divided by 4 is 0.015, plus 1 is 1.015. Up here, the exponent, you can multiply 4 and 3 to get to the 12th power. You're going to use a calculator to raise 1.015 to the 12th power. And that came out to 1.19562. Multiply that by 2,000 to get the final answer, $2,391.24. As compared to obviously starting out with 2,000, so 3 years, this account earns $391.24. It's not bad. And then here it says find the interest. All you have to do to find the interest is subtract, right? Subtract the present value from the future value, and that's your interest. So I guess kind of a different way to find the interest than what we had been doing. So anyhow, the $2,391.24 minus the 2,000 shows us that there's $391.24 in interest. And then the next few problems are very similar. Just a matter of changing up the inputs, right? Depositing 1,000, right? 1,000 goes in present value. The rate is 4%. That goes right there in the formula where the R is. divided by n, right? Still referring back to the formula. This is still, look at this, it's compounding quarterly, so n is 4, right? So that 4 goes there, and then you raise that to the power of n times t. Again, the number of compounding periods is n, t is time. So quarterly, that word quarterly tells me n is 4 compounding periods, and then it's 5 years, so t is 5. Same thing, just follow the order of operations and you've got it. It's, divide first here, then add 1, multiply your exponents, use a calculator to raise 1.01 to the 20th power, and then multiply your answer by 1,000. So $1,000 at 4% compounded quarterly will be $1,220.19 after 5 years. So carrying on, you see example 3 here. How much money should be deposited in an account today that earns 8% compounded monthly so that it will accumulate to $20,000 in 5 years? So process that. It's saying you want it to be $20,000 in 5 years. How much do you need now? How much do you need to deposit now in order to have that $20,000 in 5 years? And then that's of course based on the 8% compounded monthly. So what I have here is I actually should have showed a little more, but if you took the original formula, let me go back to that real quick. A sec here. So the original formula is here. If you were to take this formula, right, you have the future value over here. The future value equals all this. Well, if you already had the future value and you wanted the present value, here's what I did. I divided everything on this side out. So all I did is leave p. So if I divide this whole side by 1 plus r over n to the power of nt, I can cancel all that out. And then I divide this side by the same thing, a, the future value, divided by 1 plus r over n to the nt power. Again, I'm going to do that, and in doing so, I'm going to get p by itself, and that's what I'm going to use a manipulation of this formula for problems that ask me for the present value. So I'm kind of getting p by itself from the get-go. So here's that problem again, and you can see what I did. I divided both sides by that whole thing, right? A gets divided by 1 plus r over n to the nt. On the other side of the formula, when I divided by 1 plus r over n to the nt, it all canceled out and p is left over. So again, a manipulation of that formula when I need the present value, but I already have the future value. So future value is 20,000, right? That's in 5 years. So time is 5, right? 5 years. 8% is 0.08. And then compounded monthly, you guys, 12, n equals 12. So, right, there's 12 months, so if it's compounded monthly, n equals 12, and then you can see the formula here. The present value equals the future value divided by 1 plus r over n to the power of nt, right? So 8% divided by 12 to the power of 12 times 5, and I just follow the order of operations again. Here, 12 times 5 is 60. You could see that there. 0.08 divided by 12 is 0.006666 forever. Add 1 to that, and you have 1.006667. Anyhow, raise that to the 60th power, use a calculator, and you can see I got 1.4898. And then 20,000 divided by 1.4898 is $13,424.21. So to answer this question, if $13,424.21 would get deposited today to grow at an 8% rate compounded monthly, it would be $20,000 in 5 years. So same thing here. This one's asking, it's giving me some information, right? How much should be deposited today? So it wants me to find P, the present value, earning 6% compounded weekly. So your rate, 6%, 0.06. Your compounding weekly means that the number of compounding periods, N, is 52. You want it to be $10,000 in 8 years. So $10,000 is the future value, A. And then 8 years is your time, so T is 8. And again, using that same kind of a manipulation of the future value formula with compound interest, P equals a divided by 1 plus r over n to the nt, right? So you plug in your future value, 10,000, your rate, 6%, 0.06, your number of compounding periods, 52, and then it gets raised to the power of 52 times the time, the number of compounding periods times the years. And I didn't show any middle step, but either way, the present value is $6,189.55. If you deposit $6,189.55 today, it'll be $10,000 in 8 years, based on a 6% rate compounded weekly. So, and then this last formula down here, this formula called effective annual yield, it basically does this. It will calculate the compound interest rate, basically convert it to a simple interest rate yield. So again, that would be if you're earning, let's say you're earning 5% in a compound interest scenario, you can, and you have some other info, right? You have the number of compounding periods, at least n. What you can do is figure out how that would compare or convert it to a simple interest rate. It's always going to be higher, by the way. If you have a compound interest scenario like at 5%, converting it to a simple interest yield, it's going to be like 5.2% or 5.3% or something like that. So anyhow, using this formula, I'm going to click to it. This right here, using this formula, says what's the effective annual yield of an account paying 8% compounded quarterly. So again, if you use that formula, what you'll see is that 8% compounded quarterly is actually 8.24% if it were just simple interest. So compounding your interest actually gives you a higher return, which you may have already known. So I'm going to let this video be. I hope it helps as far as plugging in the correct values and whatnot, but make sure you practice and ask questions in class, guys. Thanks for having a look.